Welcome, everybody. Sorry, it's taken me just a couple of minutes to get the slides and the demo set up. Welcome to this session on flexible optimization. My name is Stephen Brook. As you might be able to tell, unfortunately I will be presenting this session in English, not in French. I know the title was in French. Thank you for letting me present in English. As I say, my name is Stephen Brook. I'm part of the Anaplan product management team. I'm based in London. I'm going to talk to you today about the optimizer feature. My colleague Boris was the lead engineer based in London, was a crucial person in the delivery of this feature, but he can't be here today to describe it. He did so for a similar session in London. So I'm going to talk to you about optimization. I'm going to try and explain for you what optimization is as a concept, and more importantly, I'm going to try and explain to you how we've packaged that capability inside Anaplan, and I'll give you a demonstration of that at the end. So what is optimization? I'll try and talk about what it is and also what it is not. So it's a technique that you can use, particularly when planning, to try and maximize or minimize a particular target. So in optimization terms, we often call that the objective function. And it's particularly useful when you've got multiple variables that you can control to try and meet that target. The example I'm going to give today is around a supply chain use case, but there are other common use cases as well. As well as the objective function, the thing we're optimizing for, and the variables we have in play, which are the things that we can change. That's what planning is all about, is coming up with options and changing things. We have constraints as well. So again, I'll explain in the context of the demonstration I'm going to give what some of the constraints might be. So in the context of a production plan, that might be the amount of capacity we have in a given factory, for instance. So why do we need optimization? Why is this a tool that we need? So imagine a really simple hypothetical scenario. So imagine that your company only makes 3 SKUs, so 3 products, and you're planning for the manufacture of those across 12 time periods, so 12 months for 1 year. Imagine that you can configure your machines so that for each SKU, you can only make 1, 2, 3, or 4 batches. There are actually 36 variables in play, but there are actually 4.7 times 10 to the power 21 feasible production plans, even in that really trivial scenario. Now imagine a real-world organization where you're planning maybe at the weekly level, maybe even at the daily level, and you're planning for hundreds, if not thousands, of products to be distributed to hundreds of retail stores. You can imagine the complexity of trying to optimize and solve for that problem manually. So if you were going to use a manual search process of maybe coming up with a hypothetical production plan, testing to see if it met all the constraints, and maybe if you decided that wasn't close enough to the optimum, dreaming up another scenario, you're probably going to end up looking like that. So there are optimization approaches, mathematical approaches that can help you discover that optimum even on really large real-world problems. Now one characteristic is that these solver engines have been available for some time to try and help you with these kind of problems. But a characterization is that they're usually configured using quite technical skills. So this is an example of the type of script that might be written to define a problem for the optimization engine that we actually use inside the Anaplan platform. But one of our objectives at Anaplan is to try and make the problem of producing a plan and automating a business process as consumable as we can. So what we've done is package the application in such a way that it really is just a logical extension of the existing Anaplan experience that you're already familiar with. So to harness the optimization capability, and I'll show you this a bit later on, you would start with an Anaplan model structure that would be very familiar with you. So you might, in a supply chain situation, already have a demand planning model, You might already have a model that builds up things like distribution costs from your product volumes and an understanding of your shipping arrangements. Those are things you might already be planning in Anaplan today. Those driver relationships you probably already have modeled in Anaplan. But what we've done is expose the ability for you to point to particular line items that define your objective function, the thing you're optimizing for. So that might be trying to minimize distribution cost or maximize profit. You identify the parts of your Anaplan model that describe the variables. So in the example I'll show later on, that might, for instance, be how I allocate demand for my product from my stores and how that will be fulfilled from a particular distribution center. And you point to Anaplan line items that define constraints. So I might have a module in my Anaplan model that defines my production capacity or the size and the location of my distribution centers. So what's the engine that's actually performing this optimization? It's actually a solver engine called Gurobi, developed by some of the leading thinkers in the operations research world. So it's a third-party tool, but we embed it inside the Anaplan platform. So the Anaplan platform itself, or the component that we call core, which is where we hold your models and do calculations, is optimized to do very rapid calculations on dynamic models and respond immediately to your user input. Optimizer is clearly, optimized for the process of optimization. That's a terrible form of words, but that optimization is its speciality, but we've embedded it in the platform in such a way that once your problem is defined inside Anaplan, the interface and the handoff to the optimization engine is treated like any other action that you would drive from user-defined action or a button on a dashboard inside Anaplan. So all of that interfacing, packaging up your problem that you've expressed in terms of Anaplan concepts like line items and lists, we hand off invisibly to the optimization engine, which then computes very quickly on specialist hardware in our Anaplan environment, and the result is then made available back in Anaplan. So the handoff to the Gurobi solver and back again is invisible to the user. Effectively, it's just another action to trigger the optimization action that the user can run from inside Anaplan. So just to recap, well, what is optimization and what it's not? Because we often get some questions around this. So currently, what we give you is the ability to solve linear optimization problems that are useful for a number of use cases. And I'll explain in a moment the important part there of what linear optimization means. The example I'm going to show you, as I've mentioned, is around supply chain. So it's a production profitability optimization problem. There are also use cases in logistics, flight allocations. We even have examples of some human resource and sales planning applications where people are looking to allocate a constrained amount of budget for things like pay rises and bonuses across a certain population of employees whilst obeying certain constraints. So it's very broadly applicable. People sometimes confuse mathematical optimization with statistical forecasting. That's a sort of separate domain. We have Anaplan applications that do that, but really it's a different type of problem. Statistical forecasting is about taking historic data and using patterns in the data to project a forecast out into the future. Optimization is more a process of taking a number of variables and trying to find the best solution out of a very large number of feasible solutions. It's also not about iterative or looping calculations. That's a question that we sometimes get. Again, in some financial modeling applications, for instance, where you're modeling a balance sheet which has a cash balance, but then on your income statement you have interest expense, which will affect your cash balance. There are requirements sometimes to have iterative type calculations. Again, Optimizer is not really a vehicle for that. And the other important aspect is that at the moment, the capability that we give you powered by the Gurobi engine, solves linear problems only. And I'll try and explain in a moment what that means. It's possible in future that we'll support a wider range of problems, because some of our customers that have come to us, we've done some work with them and surfaced the fact that they might actually have a genuine optimization problem, but it has characteristics that mean without some rework we can't necessarily support it with the solver as it stands at the moment. So the key message, I guess, at the end of this presentation is, if you have an interesting use case that you think might be applicable for Optimizer, then come and talk to us and we can try and understand a little bit more about your requirement, do some discovery and see whether or not it's a use case that Optimizer can support. So I'll give you a few brief examples of what it means to be a linear problem. Imagine for a moment that a slightly different scenario. Imagine I have a problem that I have a certain budget for a project, and either I could use internal resources that have a certain cost, or I could use external resources, say contractors, that have a different cost. So imagine resource X are my internal staff, resource Y are my external staff, and I only have a budget of, say, 10. The cost of servicing my project with a different mix of internal staff X or external staff Y might be something like 3X plus 4Y. And I might express that by saying that 3X plus 4Y is the thing I'm looking to maximize, subject to a certain constraint. So the way that problem is expressed, would you think that is or is not what we would call a linear problem? Anybody think that is a linear problem? So in that case it is. That's a problem that we can solve. Imagine your objective was that you had 3x plus 4y squared, and you wanted to subject that to certain constraints. So 3x times y plus y less than 10, 2x plus 5y less than 30. That would not be a linear problem, partly because the objective function that we're looking to solve has that y squared term in it. Again, in future that might be a problem we can solve, but right now that would not be a linear problem that Gurobi could solve. So that definitely would not be a linear problem. As an example of a requirement that we have, maybe to see if we can understand your project needs a little better, here's an example that looks similar to the first one. So imagine our objective is to maximize 3x plus 4y. That's our objective function. But we have a constraint that says 3x must be less than or equal to 10 minus y. It's not clear whether that's a linear problem or not. As it stands, as that problem is expressed, it's not a linear problem, but it could be expressed in terms of something that is. And the reason is that the linear terms must all be on one side of the equation, with the constraint being on the other. So at the moment that wouldn't be a linear problem, because 3x less than or equal to 10 minus y is not correctly formulated. But we could express that to say, actually the constraint is that 3x plus y must be less than or equal to 10. Now these are very simple examples where you only have two variables in play and some very simple constraints. As I said, the problem in a real-world implementation is that you'll most likely be dealing with hundreds of products and many millions or more permutations of ways of optimizing for your problem. So let me try and make it a bit real and give you an example inside Anaplan of a supply chain application. Let's just give the screens a moment to catch up. Okay. So in this example, imagine that we're an organization that has manufacturing plants. So we have a number of manufacturing plants here all over the world, in the Americas, in Europe, and in Asia Pacific. Our products, when they're finished, are shipped to certain distribution centers. And again, those distribution centers are in slightly different locations, but they're spread around the world. And we're selling those products ultimately through retail stores, again, which are spread all over the world. And we have a demand forecast by store. And our objective, the way our business works, is obviously our products are produced in our plants, they're shipped to our distribution centers, and then from there onwards to our customers. So we know in aggregate what our demand is, so our demand is tabulated by store. We need to match that with our understanding of what plant capacity we have. So the vertical bars on this chart here show us what the capacity of our production plants are, and we have a certain capacity in our distribution centers as well. So a distribution center only has a given size. We can't store more stock in the distribution center than we have space for. Now at the moment, down the bottom here, we have in our Anaplan model the ability to constrain and define which distribution centers can service stores in which regions. And at the moment, we have what feels to be an intuitive setup where stores in the Americas are only serviced by distribution centers in the Americas, and so on for Europe, and so on for Asia Pacific. And that makes intuitive sense, right? So if I have stores in Europe and I have a distribution center in Europe, I may as well feed the European stores from those distribution centers. Now at the moment, what we can see is that we've run an optimization previously, and we can see that we actually have a supply shortage in the United States, in Brazil, that's quite a small number, and in Asia Pacific, in Australia, and in China actually. So it might be that we could explore the option of relaxing one of those constraints. It might be that we could relax the constraint on European distribution centers. Now, why might we do that? Well, we can actually see here that currently our plant in London is underutilized, so it has excess capacity that we're not using. And actually, our distribution center in Berlin that feeds our European customers also has excess capacity. So one of the things we could do is unlock that by allowing our European distribution centers to supply customers in the Americas and in Asia Pacific. Before we do that, I'll just give you some more insight into some of the other inputs in the model. As I say, we'll get on to running the solver in a moment, but really the solver is just sitting behind the kind of Anaplan model that you would probably build to model your business in any case. So the kind of problem that we're formulating here is this one of tabulating demand. So this is demand as you would see in many of your own Anaplan models. So I've got a variety of different stores here, and I've got a variety of products. And in this case, what's happened is this is the aggregate demand that I'm sensing. And again, I might be generating that demand forecast based off statistical techniques. What the optimizer is going to help me do now is work out how best to service that demand from my manufacturing and distribution centers. And I have other settings in here as well that allow me to model things like distribution costs. So in a moment, I'm going to experiment with this idea of servicing Americas and Asia Pacific customers from my European distribution center. And as you can imagine, that might have some cost impact. But again, that's already modeled in my Anaplan model. So let me go back to my Anaplan model. And here what I'm going to do is I'm going to open up the European distribution center to allow it to service customers in Americas and Asia Pac. So I'm going to describe that scenario. So I'm going to say let EMEA distribution center service Americas and APAC customers. I may show you at the end how the optimization problem is actually configured, but as the user who actually just wants to perform the optimization, my problem is already formulated, so I just need to click a button. And that will load relatively quickly, and we'll be able to compare the original scenario that we had with the newly optimized result with that slightly relaxed constraint on how our European distribution centers can service demand from elsewhere. This is the bit that's always slightly nerve-wracking.
But you've read it before, I'm sure.
I have. I'm also hoping that the Wi-Fi is still working. Okay, so the optimization has completed. My dashboard refreshes, and now we can see that I don't have a shortfall of demand anywhere around the world. And if I were to go to my scenario analysis, I can compare and understand what's happened. So actually, this is the scenario I just created. Now what you can see is Optimizer isn't going to tell you how to run your business. It's trying to come up with optimal scenarios for you under certain given constraints. So the objective function that we gave the optimizer was to try and maximize profit. Now we can see here that in terms of a pure dollar value between the original scenario we had and the scenario we just asked for, we have an increase in profit. What you'll notice is that our gross margin has actually decreased. And of course, the reason for that is that the cost we incur of servicing those Americas and Asia Pacific customers from Europe has increased. So it's not clear whether or not that's going to be acceptable to us. That still remains a business decision. But within the bounds of the optimization scenario that we gave, that would be the optimal way of servicing the known demand through the different configurations of manufacturing plants and distribution center. And that's what you see happening over here. So you can see that our revenue in our new scenario rises slightly, our costs rise slightly more, but our gross margin decreases slightly. Now in this case, the model that models out those costs and our revenues is reasonably complex. But just to give you a feel, I can show you how it is the optimization problem itself would have been configured originally. So it's set up as an action in Anaplan, like many other actions that you would use. It's a special type called optimizer, and it's configured like this. So it's a linear problem I want to solve. I identify a particular line item in Anaplan as being my objective function, and because it's profit this time, I want to maximize it. If it were pure cost I cared about, I would minimize. The variables are the things that we give the optimization engine the flexibility to change, and that's predominantly the way it routes and matches up demand and how it services it from different combinations of distribution centers and production plants. And there's a host of constraints. So there are constraints around what are the capacities of the production plants, what are the capacities of the distribution centers, and what are the available routings. So it was one of those constraints that I changed in my Anaplan model when I allowed the European distribution center to be used more generally everywhere else. So again, once your model is built using Anaplan modeling approaches that you're already familiar with, specifying the optimization is as simple as configuring these inputs in this screen. As I say, the harder part for some use cases might be doing the work up front to verify that what you have is actually a valid linear problem that we can solve for. Okay. Oops. So let me just wrap up. So the optimizer capability, we had several pilot customers using it over the last few months. It actually became generally available a couple of months ago, so we announced it formally at the time of our hub event in Las Vegas. Depending on the licensing model you have in Anaplan, it may be included as part of your current licensing package. But if you're interested in optimization use cases, I would suggest you contact your local Anaplan team and initially try and refine the understanding of what your problem is and what you'd like to use it for. And then if it's something that you want to go ahead with and you have a project that could use it, our support team can switch on the capability for you so that you can start building and testing with it. So does anybody have any questions?
Hello. Do you have a maximum number of constraints in this functionality of optimization?
That is a good question. I would need to check on that. I don't know that there is a hard number, and certainly the Groby engine is capable of handling very complex problems. Mm. So I would need to check. Do you anticipate that you might have a problem that would be very complex, or was that just a?
Or just a question.
That's a good question. I can find out. I honestly don't know.
Okay. And another one about the functionality of a simple timestamp like now or get date or today function. Someone told me you may have information about an eventual release date.
Yeah, I don't know about a release date. It's definitely something we're looking at. So a number of customers, particularly those with supply chain requirements, would like to be able to create formula logic in their Anaplan models that identifies what today's date is, because that enables you to drive logic for things like doing stocking levels. Mm-hmm. If you know that you're partway through a week or partway through a month. The approach that some customers take today is to have a separate file which they use Anaplan Connect to sort of routinely upload that has today's date in it, and we know that isn't a great solution. It's something that we're looking at. It might seem like a simple thing, but there are things to consider in terms of the time zone that you're in and having the value of today's date tick over at the correct time depending on the time zone that you're in. Mm-hmm. So it's something that we're actively got on the roadmap, but we don't currently have a release date. We'll be posting to the community as soon as we've got more of an update when it's in active development.
Okay, thanks.
Thank you. Any other questions I can help with?
Hello. Is there some sort of sensitivity analysis possible after the optimization?
Are you meaning sort of sensitivity around the optimized result, if you sort of mean?
Yes, that will tell you this is how far you can push a certain variable until it gets...
Yeah, that's a good question. I guess that's the kind of thing you could do in Anaplan itself. I mean, it would depend what the sensitivity would be. So, I mean, if you wanted to understand the sensitivity, I guess, to some of the constraints, you could do some of the things that I was doing here. So if you... Let's imagine that your production facilities had a constraint of 10,000 units a month, and you wanted to understand what would change, whether that were maybe as low as 9,000 if you had some maintenance, or 11,000 if you were to invest in the plant, for instance. You would probably just have to model that as different scenarios. And I guess what you could do is, because the optimizer itself is driven off an Anaplan action, you could define a range of scenarios with different constraints and then run that action repeatedly to get a different set of outputs. But you're still going to need to define what those sort of sensitivity scenarios are, if you like.
Yeah. Thank you.
I have one general question which goes a bit beyond what you just described, because in my mind we talk a lot about connected planning this morning, and what you showed is, at least in my mind, much bigger than business planning, at least, like, just like supply chain, which site, which serve, which customer, etc., etc. So I think my question is, where do you see Anaplan? Because before coming in today, I was seeing only like business planning short term, where there is a solver capability, and I think this is just brilliant and bring great insight. But when I'm a bit unclear is how do you want to have Anaplan like serving much more needs and connected planning, or I think my question is what is the general vision of where you want to bring the solution? Because I think what you showed is once again absolutely brilliant, but go much beyond everything which was discussed, at least on the session I attended since this morning.
I think it's a good question. I think it depends on your vision of what you define by planning. I mean, for many people, planning has been an activity that is done in quite a traditional way and is very often something that's associated purely with the finance function. I think many of our customers, even those outside of supply chain, are using Anaplan for what you might call much more operational planning, relating sort of operational drivers to business outcomes. And the outcomes might be financial, but they are operational decisions. I think this is really an illustration of the fact that people are starting to use Anaplan more as an operational tool. And I think that is a trend that's going to increase. But you're right, I think we need to help people understand where Anaplan sort of fits in the corporate environment and the kind of things, problems that we can help them solve, and maybe areas that we're maybe still not suited for. I think this is a logical evolution of trying to solve complex problems in a flexible way and allowing you to do some sort of scenario analysis around them. We just felt it was a really good fit, and there was a lot of demand from customers for it. I think the other characteristic of supply chain is obviously that many supply chain problems, by definition, it's a chain and there are many participants involved. I think there is significant opportunity there for us to connect a number of parties, certainly outside your own organization, and again, even outside what you might call traditional manufacturing and supply chain per se, there are applications. So we're doing a project at the moment based largely out of the UK, where we have 2 airline customers that are in partnership, collaborating, using Anaplan for that. We have other instances of our customers collaborating with their other suppliers and customers and third parties, using Anaplan as a platform for doing that. So I think this idea of sort of extending the boundary of who participates in planning outside your own organization is a theme that we'll see in future as well. Any more questions I can help with? Okay, thank you very much for your time.